prove that 1 over r plus 1 bracket r plus 3 equals n bracket an plus b over 12 bracket n plus 2 bracket n plus 3, where a and b are constants to be found. So using methods of differences, we can do this question. And we need to first use partial fractions to work this out. So this 1 over r plus 1 r plus 3 can be rewritten as a over r plus 1 plus b over r plus 3. And we can multiply everything by r plus 1, r plus 3 to get rid of the denominators to make it easier to find a and b. So this will give us 1 equals a bracket r plus 3, because when we multiply r plus 3, r plus 1, this will cancel out, plus b bracket r plus 1. And now to find each of these terms, we can just set one of them to 0. So for b, we'll set a to 0. So r equals minus 3 is 1 equals minus 3 plus 3a, which is just 0, so it cancels out, plus b minus 3 plus 1, which is minus 2. So 1 equals minus 2b. And obviously, we can just divide each side by b, and we get 1 over 2. Well, minus 1 over 2 gives b. And we can just put that here so we don't forget it. And then we'll do the same thing for a. We'll do r equals minus 1. R equals minus 1. And we'll get 1 equals a bracket minus 1 plus 3. And b will cancel out, which gives us 1 equals 2a. And a will equal half. So there we go, we've got our values for a and b, but obviously it's going to be really complicated if we do half here and minus half here. So we can just take the half out, and then we can rewrite it as a is 1 over r plus 1, and b is minus 1 over r plus 3. Now what we need to do is we're going to do methods of differences, and from this we know that r is equal to 1, so we're going to start at n equals 1. Or r equals 1, and then we're going to work our way until we cancel out all the terms and we're left with this equation. So first we'll do r equals 1, and when we do this, to make it easier, we're going to take the 1 over 2 out of the bracket and do just whatever's in the bracket, and we'll deal with this later. So r equals 1 equals 1 over 1 plus 1, which is half, minus 1 over 1 plus 3, which is 1 over 4. Sorry, minus 1 over 4. And we can do the same for r equals 2, same for r equals 3, r equals 4, and r equals 5. And then we can also do r equals n minus 1 and r equals n. Now obviously there's so many more terms you can do in this because we don't actually know what n is, so n terms, right? But just for the purposes of finding out the pattern of cancelling out the terms, we'll just do it up till 5 and then do n minus 1 and n. So we'll cancel out the terms. We've got minus 1 over 4 and 1 over 4, which cancel out. 1 over 5 and minus 1 over 5 cancel out. Minus 1 over 6 and 1 over 6 cancel out. Minus 1 over 7 and the next term cancels out. Minus 1 over 8 and whatever term comes after that cancels out. And then this will cancel out eventually. This will cancel out eventually. And then we're left with these 4 terms. And then what we can do is we can add these up. And as it's inside the bracket, we'll put these inside the bracket and multiply everything by half. So we haven't forgotten about the half here. And then this 1 over 2 plus 1 over 3 can be rewritten as 5 over 6. Minus 1 over n plus 2 and minus 1 over n plus 3. Now what we need to do is, because the denominators are all different, we can multiply everything by n plus 2, n plus 3 and 6. And this is what we get here. And then we can obviously expand that, and then we can rewrite this. And we've gotten rid of the half by timesing it by 2 on the denominator. And then we can just rewrite this, and we get 5n squared plus 13n over 12 bracket n plus 2, n plus 3. But the question is asking for n on the outside of the bracket, so we can just quickly do that. And we get n bracket 5n plus 3, so a equals 5, and b equals 13 over 12 bracket n plus 2 bracket n plus 3, and that's the answer. A company operating a coal mine is concerned about the mine running out of coal. It's estimated 2.5 million tonnes of coal are left in the mine, and it wishes to mine all of this coal in 20 years. In order to mine this coal in a regulated manner, it models the amount of coal to be mined in the coming years using this formula. where MR is the amount of coal in millions of tons mined with the year R, or mined in the year R, with the first year being year 1. Show that according to the model, the total amount of coal in millions of tons mined in the first n years is given by this equation, where K is a constant to be determined. So again, like the last question, we're going to do partial fractions and methods of differences. So first we're going to do our partial fractions. We'll do 10 over r squared plus 8r plus 15 equals a over r plus 3 and b over r plus 5. You just need to factorize this to find this out. And then we need to get rid of this and denominator on both sides. So we'll multiply everything by r plus 3 and r plus 5, which gets rid of this, which gives us 10. It will get rid of r plus 3 and give r plus 5a, and it will get rid of r plus 5 on the b part and give us b bracket r plus 3. And then to find out a and b individually, we just set r to either minus 5 or 3, or minus 3 to make one of these values 0. I'm going a bit fast, but it's self-explanatory. So r equals minus 5. 10 will equal minus 5 plus 5a, which is just 0, so it cancels out, plus b bracket minus 5 plus 3, which is minus 2. So 10 equals minus 2b, and b will equal minus 5. And we'll do the exact same for the next part. We'll do r equals, this should be a 3. r equals minus 3. And then you've got 10 equals a bracket minus 3 plus 5 plus b bracket minus 3 plus 3. So the b will cancel out and you're left with 10 equals 2a and a equals 5. Okay, so our a is 5 and our b is minus 5, and we can put that back into this equation. And then we can rewrite this formula, and we've got this just equals this with the bracket 1 over r plus 3 minus 1 over r plus 5, and we've got the 5 on the outside. And the same like last time, we're just going to do our partial fractions. So r equals 1, and then we use this equation, so 1 over 1 plus 3, which gives 1 over 4, minus 1 over 1 plus 5, which is minus 1 over 6. And you just keep doing the same until we get to r equals n. So I've stopped at 4 here, and then I've gone to r equals minus n minus 1 and r equals n. And from this we can see that these terms cancel out and these terms cancel out, and so forth. And obviously we haven't gone further with this and then r equals 5, etc. We've just jumped straight to r equals n, but we can assume that these will eventually cancel out. This will eventually cancel out, that will eventually cancel out, and you're left with 1 over 4, 1 over 5, minus 1 over n plus 4, and minus 1 over n plus 5. And then we can just add these up and obviously multiply it by 5 from earlier. So it's here n equals 5 bracket all of this, and then we can rewrite this. So that will give us 9 over 20 minus 1 over n plus 4 minus 1 over n plus 5. And then we can multiply everything by n plus 4 and n plus 5 and 20, which gives us this. And then we can just continue to expand it and group all the like terms together until we get this. And as you can see, 4 is outside the bracket, so k equals 4. Okay, part B. Explain why, according to this model, the mine will never run out of coal. So, as n becomes a very large number, the n squared terms in the formula dominate the expression. And this is the formula from earlier, so this one. And we can see that these are our n squared terms. When n is extremely large, the smaller terms like 41n and 80 and 36n become insignificant. We can approximate the total as 9n squared over 4n squared as n tends to infinity, and this can be simplified to 9 over 4, and 9 over 4 gives us 2.25. Since the sum is increasing towards 2.25, which is less than 2.5, Tn can never reach 2.5. So basically it means it will never reach 2.5, as in it will never mine up until 2.5 million, so it will never run out, and the remaining tons of coal will never be mined at all, no matter how long the company keeps mining. That could be 1,000, 100 million years, and it will just never stop as it tends to infinity. Use the Maclaurin series expansion for cos x to determine the series expansion of cos squared x over 3 in ascending powers of x up to and including the term in x to the power of 4. Give each term in its simplest form. Okay, so we need to use the double angle formula for cos squared x because we don't want to be dealing with cos squared x, we just want cos x on its own. And this will give half bracket 1 plus cos 2x, so now we're just dealing with cos 2x. And we put this x over 3 into this formula where the x is, and we get half bracket 1 plus cos 2x over 3. And from this point we can just set u or x, wherever it is, to 2x over 3. And then we'll just work out what each of these will be. It says only until x to the power 4, so we just need that. So obviously x squared over 2 factorial plus x to the power of 4 factorial, and then this will give 1 minus, and then this expanded and that expanded. So obviously using our cos squared x formula from earlier, we just need to put this entire thing back into here, like so, and then we can just expand that out, and this is what you get. Use the method of differences to prove that for n is greater than 2, ln r plus 1 over r minus 1 equals ln bracket n plus 1 over 2. So first we need to use our laws of logarithms, and this states that ln a over b equals ln a minus ln b. And we can apply this over here where we have ln r plus 1 minus ln r minus 1 from here, as you can see. And now we're going to do our method of differences. So we're going to start from r equals 2, as that's what's given in the question. And we can just do it for each of these parts. So when it starts from 2, r equals 2, this equals ln 3, and this equals ln 1, or minus ln 1. And then you do the same for 3. 3 plus 1 gives ln 4, minus ln 3 minus 1 gives minus ln 2. And then you keep going up until r equals n. And now we can do our cancelling out. So we can see that ln 3 and minus ln 3 cancels out. Same goes for ln 4. Same will go for ln 5 and ln 6 eventually. And then we can obviously assume that this will cancel out and this will cancel out, and then you'll be left with this. So now all we need to do is add these terms. And obviously we know that ln 1 is just going to equal 0, so this cancels out. And we get that. And then we need to use our laws of logarithms again. And we're going to just also rewrite this. And one of the laws states that ln a plus ln b equals ln a times b. So this bit here will just be ln n bracket n plus 1. And ln a minus ln b equals ln a over b. We know that from earlier. So this will be over this part. We've done this part first, and then that will go into like that. I don't know if that was a good explanation or not, but you can sort of see where I'm coming from. And then I've accidentally not taken this out, but just ignore that and pretend it's here. So yeah, that's your answer. Hence, find the exact value of this. Give your exact answer in the form a ln bracket b over c, where a, b and c are integers to be determined. Okay, so what we need to do is we need to do this sum of this 100 times minus sum of this 50 times. So we've got 35 as a power here, so we can actually bring this to the front. So we can rewrite this like this. And then to work out the sum of the terms from starting from 51 all the way to 100, we need to do the sum of all the terms to 100 minus the sum of all the terms up until 50. So we can do that, and we can start from 100, and we use this from earlier. And yeah, starting from n equals 100, we can just put n back into this equation, and that will give us ln 5050. And then using n equals 50, we'll get ln 1275, and remember we need to minus these. So it's ln 5050 minus ln 1275. Using our laws of logarithms from earlier, we know that this will just be ln 5050 over 1275. But not to forget, we've got 35 in the front. So we also need to multiply this by 35 on this side, which is also where you see the a come in at the front. And then we can also simplify this fraction, which gives us 35 ln 202 over 51. Given that y equals e to the power of x sine x, show that y differentiated 6 times equals k, and then y differentiated twice, where k is a constant to be determined. So what we need to do first is we need to differentiate this y. So we've got y equals e to the power of x sine x, and then when you differentiate that, you get e to the power of x sine x plus e to the power of x cos x. Obviously, I'm not going to spend too much time actually explaining how to differentiate that, because that's not really the core part of this topic, but yeah, so I'm just going to keep skipping this. And also from here, we can also simplify these terms. We can just cancel out these sine x, and then we've got this, and we'll do all the way up until y is differentiated 4 times. And then interestingly, what we learn is that, or what we can see is that once we differentiate it 4 times, this looks very familiar to this. So y differentiated 4 times is essentially y times minus 4. So this equals minus 4. So we can say that y differentiated 5 times will give minus 4 times y differentiated once. Because obviously if we simplify this and get rid of that, this will just be the same as this, right? Y differentiated 4 times equals minus 4y. So y differentiated 5 times must give minus 4y differentiated once. And we can say the same for 6. We can say that y differentiated 6 times equals minus 4 times y differentiated twice. And is that not what this is saying in the question? It's saying y differentiated 6 times equals something times y differentiated twice. And that something is minus 4. So we can say k equals minus 4. Hence, determine the first 5 non-zero terms in the Maclaurin series expansion for y, giving each coefficient in the simplest form. So these are just everything differentiated, and then we set all of these to x equals 0 here, and this will give 0, and obviously we know that e to the power of x is 1, cos x equals 1, so this will be 1, and this is just 0 because sine x is 0, so 0 plus 1 is 1. You can say that if e to the power of x cos x is 1, then that times 2 is 2, and you just keep doing that basically. And we've only got 1, 2, 3, and we need 5 non-zero terms, so we have to keep going. And this will give minus 4, and this will give minus 8, and now we've got 5 non-zero terms. And then using our Maclaurin series formula here, we can just put these back into the equation. Y differentiated once is just 1, so that will just be x. And then this f of differentiated twice, 0, is 2 over 2 factorial will just give 1, so it's just x squared. And then obviously we know that y differentiated 3 times is 2 over 3 factorial give 1 over 3, so that's 1 over 3x cubed. And then if we skip all the way to y to the power of, or not power, y differentiated to 5 times is minus 4 over 5 factorial, which is minus 1 over 30. And then we've got minus 8 over 6 factorial, and that will give us minus 1 over 90 x to the power of 6, and that's it.